Hi, Year 12 General Maths students. In this lesson, we're looking at a Unit 4 topic. In Topic 1, investigating the effects of interest and compounding periods on graphs of compound interest scenarios. So we're addressing the second point in the syllabus, and our lesson objectives are visually comparing simple and compound interest growth in Excel, investigating the effects of changing the interest rate and number of compound periods, and developing recurrence relations to then compare loan or investment choices with differing interest and compound periods. Alrighty, so let's first compare the visual differences between using compound and simple interest. So this is just a typical graph that you might see if they're being compared. Just notice that the simple interest is a linear relationship or a straight line because it grows by a constant amount every year. Whereas the compound interest has this lovely curve shape. It shows exponential growth, which is non-linear because it grows by an increasing amount each year. So we're going to have a little bit of a closer look using a spreadsheet that I put together in Excel to visually see what happens to the growth of investments or loans when we play around with things like the interest rate and compounding periods. And I'm also going to have a play around with the principal as well, so you can see how much more interest you have to pay over time. All right, so I'm going to open up this spreadsheet and we'll have a look. All right, so the initial loan that I'm going to look at or investment is going to start off with a principal of $10,000 and an interest rate of 5% per annum. And the way I've set it up is just showing you how it grows using simple interest. Then we move on to compound interest, which is more the focus of Year 12 General Maths. And you'll see here that I'm just changing the compounding periods. So this one has a K of 1, which means it gets hit with interest once a year. As we move along, we see a comparison if it gets hit monthly, fortnightly, and weekly. Okay, so they all use that same amount of principal amount of $10,000, and you can see that depending on the K value, the interest rate that it gets hit with per compounding period changes. And you can see down the bottom here that that affects the total interest earned or charged, depending on if it's an interest investment or loan. So down the bottom, you can see that a simple interest over a 20-year loan of $10,000, you're paying interest of $10,000. So it's essentially double what you borrowed. As we move along to compound interest, that same $10,000 at the same rate, because it's compounding and you're increasing by paying interest on the interest, the total interest paid at the end of the loan is $16,533. If we compound that monthly, so it gets hit 12 times a year, you'll end up paying $17,126. If we move along to fortnightly and weekly, so fortnightly gets hit 26 times a year, you'll earn or be charged $17,157 for fortnightly and $17,170 for weekly. So the trend you should be noticing is that the more it's hit with interest, so the more compounding period per year, the amount of interest you pay increases. And you'll notice there's only slight increases between the monthly, fortnightly, and weekly, but it's still an increase, which is the important point. If we have a look at graphical comparisons, again, you can see that we get this linear for simple and the curve for compound interest. And if we look at comparing the amount of interest you've paid over that 20-year loan, the simple's the least, and then it increases. And there's a very slight increase, as you can notice here, between the monthly, fortnightly, and weekly. If we come back and play around with the interest rate, so we've already observed that if you increase the number of compounding periods, the amount of interest you pay increases. Let's have a look what happens when you increase the interest rate. So I'm going to change it to 8%. You can see the flow-on effect. So simple interest, you're paying $16,000 interest, and then we get our massive jumps with our compound interest, and you can see again the amount of interest as you go along with those increasing compounding periods increases as well. Again, you see the change in our graphical displays, so you can visualize what's happening there. Say we changed it to a $100,000 loan. So you notice the amount of interest you're paying jumps up massively, which is understandable because you're borrowing more. And again, you're seeing that increase in interest as you scroll along. Same pattern. Okay, so the takeaway from that is you should have noticed that increasing number of compounding periods, your K value per year, will mean that you pay more interest or you earn more interest, depending on whether it's a loan or an investment. The more you borrow, the more interest you'll pay or you'll earn, and more importantly, the higher the interest rate, the more interest you earn or get charged. So what does this mean in terms of loans and investments? Well, the logical thing is when you take out a loan, you want to pay less interest. So you're going to choose a loan with a low interest rate that compounds a minimum times over a year. And then the complete opposite when you're making an investment. You want to make more interest. So you're going to choose an investment with a higher interest rate and that compounds as often as you can get over the period of a year. All right, so let's have a look at some questions that we could be asked in assessment using what we now know about changing interest rates or compounding periods. The first one, we've got a investment situation. The principal is $8,000 and a nominal interest rate of 5.2% per annum. And looking at the question, it wants us to develop a recursion relation for differing compounding periods per year. So it looks like we've got to do once, 4 times, so quarterly, 12 times, so monthly, 26, so fortnightly, and 52 weekly. Okay, so a bit of work involved there. Now, I've also put together this recurrence relation spreadsheet to help us do this. So rather than doing these recursions in our calculator, we can use Excel as a tool to speed up this process. So part B asks us if we close the investment after a year, let's work out how much extra interest was earned by choosing monthly compounds instead of an annual compound. And then lastly, if this was a loan that was paid out after 1 year, how much interest is saved by choosing monthly compounds instead of weekly compounds? Okay, so this is the spreadsheet I've set up. So the way it works is we just pop in our principal. So in this case, we want $8,000. The nominal interest rate was 5.2% per annum. And you can see over here, it spits out that R value for us. So when it comes to doing A, we can easily put together those recurrence relations. And I've just set up a simple recursion where your A to the N column tells you the number of recursions you're applying. So because the first one we're after is a compounding period of 1, that just means it gets hit once a year, we're going to refer to this column to see that after a year being hit once, we have a final balance of $8,416. Okay, so I just copied the table over from part A just so we can paste in those values that we find. For the second one, we want 4 compounding periods. So notice that the R value changes, and because we're after 4 compounding periods, we can see that after a year, the balance on the account is $8,424.18. Changing it to 12 compounding periods, so monthly, we'll refer to this one here because there's been 12 recursions, and we can see that monthly $8,426.06 is the balance in the account. For the next one, changing this to 26, and we'll have to scroll down just a little bit to find 26 recursions, and we can see that your balance would increase a little bit even more, and then we need to change the last compounding period that we're after to 52, and you'll notice the rate changes again, and we scroll right down to here, and that is $8,426.79 in the account. Alright, so just popping back, we've now completed our table to finish A. You can have a look closely that again we're seeing that pattern of increasing the number of compounds per year increases the balance because you're earning more interest in this investment situation. Okay, addressing B says we need to essentially compare the monthly to the annual balance, and we want to know how much extra interest we earned. So in B, we're comparing these two, and for C, we're comparing the monthly and weekly. Okay, so if I document that, you can see that I'm just comparing the monthly versus yearly balances for B in an investment situation. So if I was to choose an investment that had monthly compounds, I'd earn an extra $10.06 for that first year. And then for this part C, where we're looking at the loan situation, looking at if it compounded weekly compared to compounding monthly, you could see that I would save 73 cents by choosing the monthly compounding period in that loan. And although that doesn't seem much, over time it does increase. So the moral of the story is choosing more compounding periods if you want investments, less compounding periods if you want a loan situation. Okay, the last two example questions that I've put together is they're essentially the same structure, except one I've written as a simple familiar type question you may be asked, and the second one I've put it in a complex familiar type format. So you can see a simple familiar, you kind of step through what you need to find. Complex familiar, you've got to make those decisions yourself. Okay, so in example question 2, we've got Dave, good old Davo. He's looking to invest $9 grand of his money in a particular finance company that offers 2 investment interest options. So investment A, 3.7% per annum compounded weekly. Investment B, 3.8% per annum compounded fortnightly. We have to develop recursion models for investment A and investment B, and then calculate the interest earned for both investments over the period of 1 year. From that, we have to decide which of the 2 investment opportunities Dave should take based on our findings. In example 3, Sally's got a choice of 2 loans. Option 1, 5.2% per annum adjusted quarterly. Option 2, 5.1% per annum adjusted monthly. She's borrowing $5,000 over 2 years. We need to use a recursion model to help determine which loan will be better for her to take. Just before we start doing the second and third examples, I'm just going to pop back up to question 1. In hindsight, I realised I forgot to state those recursion relations. So from Excel, I just grabbed the R values, and these are the recursion relations you should have come up with. All right, let's move on to the questions. So, again, good idea to identify any important information. So he's looking to invest $9,000. So that's going to be our initial value. With our interest rates, the rate's obviously going to be the I value, and for compounding weekly, we've got a K of 52, and fortnightly a K of 26. Okay, so for part A, where we had to develop recursion models, we just had to recall our little formula where we have to identify the R value using the interest and the compounding periods. So for investment A, which was weekly, we had an R value of 1.0071, giving us a recurrence relation as seen there. For fortnightly, we end up getting an R value of 1.00146, giving us the fortnightly recursion relation. So part B, we're going to be using those recurrence relations to find a balance, and then we can work out from the balance, work out the interest earned for both investments. Okay, so if we pop over to our recursion spreadsheet to help us quickly process those recursions, investment A was 3.7% compounding weekly, so we pop that in. We can scroll down and see that you would end up with a balance of $9,339.11. If we change that to our 3.8% per annum compounding fortnightly, you can scroll down and see that we'll get a balance of $9,348.32. So because we're excellent mathematics students, we would then document how we completed that recursion process. So I'd just like to see a couple of recursions demonstrating you know how to do it. We've got our final balance, and then we know the interest earned, which is the aim of the question, is your final balance minus your principal, which was $9,000. So with investment A, we got $339.11. Investment B, final balance $9,348.32 minus your initial $9,000 left us with $348.32 of interest earned for investment B. Okay, so just finishing off the question, part C wants us to decide which of the two investment opportunities Old Davo should take. So considering it was an investment situation, we want to choose the option that earns us more interest over time. So you would recommend option B because of that reason. Moving on to question 3, I'd like to have a go at that question yourselves using that same process. So finding a recursion model for both options, using that spreadsheet to work those recursions, and then making a decision on a loan situation. So pause the video, have a go at the question yourself, and I'll come back to you. How'd you go? So hopefully when you process the question, you identified your interest, your compounding periods, the fact that you're borrowing $5,000, and really important information is the 2 years. So you're doubling the amount of recursions. Okay, so from option 1, I used the spreadsheet. So I popped in the principal, nominal interest rate, compounding periods, and because we're after double the amount of recursions, this would be our final balance after 2 years. So that's 8 recursions. And you should have ended up with a balance of $5,544.29, which meant you got charged $544.29 interest using option 1. Okay, so if we pop our second option into our little recursion spreadsheet, we scroll down to 24 recursions because over 2 years you'll be hit with interest 24 times. So for the second option, Sally will be, if she chooses it, she would be charged $535.72 interest. So to answer the question, the recommendation to Sally would be to choose option 1 because she'll be charged less interest over the 2-year loan. You can see that option 1 has less interest than option 2. Okay, Year 12, so hopefully by the end of this lesson you've observed that with loan or investment scenarios, compounding interest as opposed to simple will accrue interest more quickly. When we look at compounding interest loans or investments, if you increase the number of compounding periods or if you increase the interest rate, you'll have more interest earned or charged depending on whether it's a investment or loan. So when you take out a loan, we want to choose a loan with a low interest rate that compounds a minimum times. When you're choosing an investment, hopefully you'll choose the investment with a high interest rate that compounds as often as you can, because you're trying to maximize the interest you earn over that investment period.